So these are examples of homework 6, solving radical equations. Number 1, we have square root of 3a plus 1 equals 7. So we need to make sure that we isolate the radical, and this is the radical. It is isolated. It's by itself on one side of the equal sign. So then, because this is a square root, we will square both sides of the equal sign. And so when you do that, you get rid of that square root. And so now we will have 3a plus 1, so anything that's under the radical, equals, and then we actually square this, so 7 squared is 49. And then we continue to solve for the variable. So minus 1 on both sides of the equal sign. (3a) equals 48. Divide by 3. Divide by 3. A equals 16. And to make sure that that really does work, we are going to do a check. And so when you do the check, you rewrite the equation. So 3a plus 1, the square root of 3a plus 1 equals 7. And then now I'm going to substitute this 16 into the a. So I still have the square root, 3, and instead of the a, I'm going to put 16 plus 1. And so I'm trying to find out if this equals this. So 3 times the 16 was 48 plus 1. And then I need to add the 48 plus 1. The square root of 49 is 7. So because this checked out, that means that this is the correct answer. And it is a valid answer. So A equals 16. On number 2, I have square root of 3y plus 3, and then the minus 4 is not under the radical, equals 5. So this radical is not completely by itself. I need to get rid of this minus 4. So I'm going to add 4 to both sides of the equal sign. And then I will have square root of 3y plus 3 equals, the 5 plus 4 is 9, because that goes away. And now I have the radical isolated, and since it's a square root, I will square both sides of the equal sign. So when you square a square root, you are getting rid of the radical sign. So now 3y plus 3 is out of the radical sign. 9 times 9 gives us 81. And then we proceed to solve for y. So minus 3 on both sides of the equal sign. 3y equals 78. Then I'm going to divide by 3. Y equals 26. And so now I'm going to do the check. So I'm going to rewrite the equation, which was square root of 3y plus 3. The minus 4 is outside the radical. And now I will substitute in this 26. So square root of 3 times, and instead of the y, I'm going to put 26 plus 3. Minus 4 is outside the radical. And then I'm just going to simplify. So 3 times the 26 is 78 plus 3. The minus 4 is still outside the radical. So then my 78 plus 3 was 81. The minus 4 is outside the radical. Square root of 81 is 9. Minus 4 equals 5. So now 9 minus 4, 5 equals 5. And because this checks out, it means that this is the correct answer. Y equals 26 is my correct answer. So on number 3, I have 3 times the square root of x, and then the minus 27 is not under the radical, equals 21. So I need to get this radical completely by itself. So if it were just a variable, I would minus that 27. Well, actually get rid of that minus 27, so plus 27. So I'll have 3 times the square root of x. That's gone. Equals, and then I've got 21 plus 27 gives me 48. And then just like if this were a variable, divide by 3. So square root of x equals 16. And now I'm ready to, because the radical is isolated. So now I'm going to square it because it is a square root. So I'm going to square both sides. So when you square a square root, you're getting rid of the radical sign. So x equals, and then 16 times 16 is 256. So again, to make sure that that is correct, I'm going to do a check. So I rewrite the original equation, making sure that I don't put that 27 under the radical. So now I'm going to substitute this 256 into the x. And then I'm going to simplify. So the square root of 256 is 16, so it's no longer in the radical, but I am multiplying it times that 3. And then copying the rest of the problem. So now 3 times 16 gives me the 48. And 48 minus the 27 is 21. And since this checks out, that means that x equals 256 is my answer. On number 4, this time I don't have a square root. I have a, this is to the 4th. So this is a 4th root. So 4th root of 5x plus 2. My minus 3 is not under the radical, equals 0. So I need to get this radical isolated. So I'm going to add 3. to both sides of the equal sign. So now I have, and make sure when you rewrite this that you put the correct number in the index right there. So the fourth root of 5x plus 2 equals 3. Now that my radical is isolated, I am going to, instead of squaring, I am going to raise this to the fourth power because I need to get rid of the fourth root. So if I raise that to the fourth power on the left side of the equal sign, I have to do that on the right side of the equal sign also. So when you raise a fourth root to the fourth power, you're getting rid of the radical sign, and you will just have the 5x plus 2 equals, and then make sure that you're doing to the fourth power. So this means 3 times 3 times 3 times 3. So 81. Then I'm going to solve for the x. So 5x equals 79. And I know this is ugly, but we are just going to have a fraction for an answer. So I got x equals 79 over 5. I'm going to do the check, just like I did all the other ones. So when you do the check, make sure that you get the right index. So it's the fourth root. So now I'm going to substitute in the 79 over 5. Fourth root. So 5, and then times, instead of the x, I have 79 over 5. Now the good thing about this is that 5 is on top and this 5 is on bottom, so those will cancel. So then your next line will be, you won't have the fraction anymore. So now, and 79 plus 2 is the 81. So make sure when you're trying to find the fourth root of 81, when you go into your Desmos, make sure that you're finding the fourth root and not the square root. So when you go into the Desmos scientific calculator, here's your scientific calculator. You are going to find the button that says to the nth root and click on it. And then mine was to the fourth root, so I'm going to put a 4 there. And it was the fourth root of 81. And so it will give you whatever root you're looking for. So the fourth root of 81 is 3. Then I can come back over. And so the fourth root of 81 was 3. Minus the 3 equals 0. And since this checked out, then my answer is 79 over 5. Okay, number 5 looks a little different. X equals square root 2x minus 12, and then the plus 6 is not inside the radical. So we do have to isolate this radical. So I'm going to subtract 6 on both sides of my equal sign. And so now this becomes x minus 6 equals square root 2x minus 12. Now that this is isolated, I am going to square both sides of the equal sign. Well, when you have a binomial like this, x minus 6 squared, it's actually x minus 6 in parentheses times x minus 6 in parentheses. And then when you square a square root, you get rid of the radical sign. And so on this side of the equal sign, we're going to have to FOIL. So the x times x gives me x squared. X times negative 6, negative 6x. Negative 6 times x, negative 6x. Negative 6 times negative 6, positive 36. And then I do have terms that combine, so x squared minus 12x plus 36. And then I still have this, so equals 2x minus 12. When we have a squared term, we need this equation to equal 0. So we will need to subtract 2x and add 12 to both sides of the equal sign. So now I have x squared minus 14x plus 48 equals 0. And then when we get to this point, you can do the quadratic formula. You can split the middle. So I'm going to split the middle. So when I do that, I'm going to end up with 2 parentheses. And so I know that negative 6 times negative 8 will give me the positive 48. And when I add negative 6 and negative 8, I'm going to get negative 14. So now I set each of those equal to 0. And then solve for x. Oh my, let me fix that. And since we have 2 answers, we have to check both of them. So my first check, I'm going to be checking to see if 6 works. So for the x, I'm going to put a 6. And then for this x, I'm going to put a 6. And then I'm just going to simplify. So 2 times the 6 is 12. Okay, square root of 0 is 0. So since that works, I do know that 6 is one of my answers. So then we move on and we do check number 2. And so I'm going to be checking the answer of 8. So I'm going to put an 8 in for the x, an 8 in for the x here. Okay, 16 minus the 12 is 4. Square root of 4 is 2. So this one checks out also. So both of these are accurate answers for that problem. So number 6, I have square root of 7y plus 5 minus square root 6y plus 7 equals 0. Well, I need to isolate the radical. Well, since I have 2, I need them to be isolated, one on one side of the equal sign, one on the other. So I'm going to add the square root of 6y plus 7 on both sides of my equal sign. So now I'll have square root of 7y plus 5 equals square root 6y plus 7. To get rid of the radical signs, because they are square roots, I will square both sides of the equal sign. And when you square a square root, you're getting rid of the radical sign. So now I have 7y plus 5 equals 6y plus 7. I'm going to solve for y. So I'm going to subtract 6y on both sides of the equal sign. So now I have y plus 5 equals 7, minus 5 on both sides. Y equals 2. And so if you put the 2 back in, so right here I would have 7 times 2 is 14 plus 5. So that would end up being the square root of 19. And then here I'd have 6 times 2, which is 12, plus 7, which is the square root of 19. So the square root of 19 does equal the square root of 19. So that is my answer. And the last one is a cube root. So again, we need to isolate the radical. So I'm going to add 5 to both sides of the equal sign. So cube root of 3x minus 4 equals 9. And then to get rid of a cube root, we will cube or raise each side to the third power. So that leaves me with 3x minus 4 equals, and 9 times 9 times 9 is 729. Then I will add 4 on both sides of the equal sign. 3x equals 733. Divide by 3. Again, it's ugly, but our answer will just be, ooh, I forgot the equal sign. Will just be a fraction. So because this is kind of weird, we'll do our check over here. So cube root of 3 times 733 over 3 minus 4. And then minus 5 is on, minus 5 is on the outside of the equal sign, or outside of the radical sign. So those threes cancel. So the cube root of 733 minus 4 minus 5 equals 4. Cube root of 729 minus 5 equals 4. The cube root of 729, again, you can put that in your Desmos calculator. 9 minus 5 equals 4. And because that checks out, that is my answer.